Assalamualaikum and good morning to Dr. Zul. So we're gonna present about sustainability for shoes rack. But first, I will introduce our group. My name is Faisal. This is Fong Zu Yang. This is Ting Hieng and Soh Shi Ling. I will present about the life cycle of the shoes rack. For the original shoes rack, for the tube, hollow tube, the process that involved is the plastic molding process from plastic granule. After that, when the hollow tube is produced, we will drill the tube to become like this. For the base, this base, the process involved is injection molding process, also from plastic granule. For the cushion, we use material polyurethane sheet. The process involved is lamination process, then coating process to produce fiber leather. Then we will combine it with the cotton to make a cushion. For the support, we use the iron tube. The process involved is piercing process, grinding process, and drilling process. For the new shoes rack, we use major material is wood. So the process involved to making the left and right side and bottom side and back side is cutting process, bandsaw process, and sieving process. For the cushion, the material is we use fabric and we combine it with the cotton through the sieving process to make a cushion. For this part, we use the aluminium metal sheet. The process involved is punching process. Then we make the finishing. Then we spraying it. For this and base part and the front cover part, we use the polypropylene granule. The process involved is injection molding to make the front cover stand, shoe support. Then the front cover and shoe support, we combine it to become like this. So that's all from me.
Equal weight. The equal design weight is a qualitative method of the analysis products using working in group or individually. The aim of this equal weight is to indicate the area of the product that can be redesigned to improve its environmental and sustainability. By comparing the both equal weight of the original shoe threads and new shoe threads, the overall performance and sustainability is enhanced and improved. The score of the new way of doing it. Product use, distribution of the original and new shoe thread is remain the same. This is because the function of the new shoe thread and original shoe thread is still the same and the distance to transfer also the same. While the material selection, material uses, optimize life, and end of the life of the new shoe thread is better than original shoe thread. This is because the work is natural resource non-hazardous, biodegradable, recyclable as compared to the plastic and metal. It is also to improve the reliability and maintainability. The wood has the better resistance and offers higher stress and weight. And the material also using the less energy. So the new substrate of the eco weight is better than original rest. That's all for my part.
Eco indicator. So we will using the result getting from the eco indicator to compare the new substrate and also the original substrate. So first thing we will doing is about the production of the new substrate and also the old substrate. So the first thing is the material or processes. The first one will be the polypropylene, which has 0.53 kilogram in the new substrate, and the data getting from the indicator is 330. So 0.35 times 330 will get the 174.9. So the next thing is the aluminum. Aluminum has 0.8 kilograms. All these amounts and volume and also the weight of the material is getting from our design which create inside the solid wood, so that we can use it in the indicator. So all of this material will getting its volume and also its weight and time with the data that we getting from the indicator, so that we can getting this result. So for the wood masses, we will get about 26.8. Fabric will get about 48. Injection molding propylene will getting about 11.13. Stamping aluminum will get about 1.8. And also the gearing will get about 9.8. So after that, we need to sum out this all of the result to getting this 896.43. So same with the original substrate. We also need to getting the amount which is in kilogram for this material, then time with this indicator value, so that we can getting the result of the eco indicator. So for the original substrate, it has the PU plus cotton material, cast iron, and injection molding propylene, piercing, gearing. So for the PU plus cotton, it will get 192. Cast iron will get about 974.4. Then the injection molding propylene will get about 11.13. Piercing and gearing will get 362.4 and 9.8 respectively. So we will get about 1549.73 for the original substrate. So at here we can see that the new substrate has a lower value of eco indicator, which means that the new substrate is more eco-friendly and better sustainability. So next we proceed to the transport, energy, and also the auxiliary material. So for the new substrate, the process of transport is using truck with 28 tons volume. So the amount is for the substrate is in 4.5 meter cube km. So the indicator data we're getting about X for this kind of transport in this amount. So to get the result, 4.5 times X, we're getting the 36. So there will be the result of the transport. So look for the original source rate, the transport, which is the same as the new source rate using 28 tons truck, and the amount also the same as the new source rate, which is 4.5 meter cube km. So time with the X, getting the 36. So for the next, we'll proceed to the disposal process of every type of material. The first one is PP. So recycling PP for the new source rate, we have recycling all of the PP. So the volume will be same as the top here, which is 0.5 kilogram. So time with the data getting from the echo indicator. So we have get the negative 111.3. So after that, the aluminum go with the same thing, which is has 0.8 kilograms for recycling. So time with the data getting from the echo indicator, we are getting the negative 576. So the total result is negative 687.3. So to calculate the grand total, we have to subtract the 896.43 with this negative 687.3. So we were getting about the grand total is 245.13. So for the original substrate, there has also disposal process, which is recycling of PP and recycling of cast iron. Of this, this result is getting from the echo indicator. So this one times this, we're getting the negative 111.3. For the cast iron, we're getting about negative 284.2. So total, you will get about negative 395.5. So after that, to get the grand total, which using the same method, which using subtract the 1549.73 to the negative 395.5. So we're getting the grand total, which is about 1190.23. This is 1549.73 minus 395.5. Okay, that's all for the echo indicator.
Structures in terms of different tiles of the original shoes rack and comparing to the new shoes rack. As we can see from the new shoes rack, the impact percentage is giving average into each parts of the shoes rack. But in original shoes racks, the impact is giving only to the shipments of the cushions. This is because in terms of the tiles tool, the cushions is made from the fabric, synthetic fabrics. So maybe from the electricities for making the synthetic fabrics is causing more pollutants to the environment. So from this, we can see for making original shoes racks, it needed cast irons, steel, and the cushions. So the electricity will be only 2, but the materials will be 3. So in the new shoes rack, we will divide it into 5 parts. The first part is the materials, and then followed by the electricity. The materials actually will be converted into 5 different materials, and the impacts also divided into 5 different impacts. This is because the electricity for each part is almost the same for the shoes rack, for the new shoes rack. Thank you. For the first graph, as we can see from here, the characterizations of the graph is divided into many elements. Few elements like climate change and the material degradations. First, I will explain about the characterizations of the climate change. For the first one, like the green color is indicate the stripping of the some parts of the shoes racks. So as we can see, the impacts is high on the red colors bars. Actually is one of the parts from the shoes racks. The characterizations actually is very important for us to know about which is the most impact during the shipment and producing the parts. In this case, actually the most impact parts is the red colors that actually is indicated below. After that, we can see the damage assessment bar graph is indicated in 3 terms, but in 3 different elements. First, the red colors, green colors, and yellow colors. You can see the part from the bottoms that's indicated below. So as comparing by the three colors of the parts that indicate different parts. The first, red, actually is giving the huge impacts when comparing to the green and yellow colors. Actually, the normalization and the weight looks similar to the damage assessment. The only difference is the scale indicators. Okay, next, the single score actually is convert from damage assessment, normalization, and weight. First, the yellow color is stacked after the green colors, and then the red colors. Why they need to do like this? This is because this is easier for the readers to compare each others within the shipment of each part. This is unlike the damage assessment, normalization, and weight because they're comparing each others in terms of elements, but in single score, they compare each other in terms of the parts. Yes, let's move on to my next. This is the damage categories in terms of human health, ecosystem, resources. Actually, this is reflects on the damage assessments. The 0.5 and so on actually is from the bars. So as we can see, the cast iron giving a huge impact in the total number of score and followed by cushion and stand.
Substrate result from the CMAP will display the characterization, damage assessment, normalization, weak, and single score result. From all of these will combine to become the single score. From the single score result graph, the red is the higher damage than other part. And overall of the substrate is better. Substrate result is better than all original substrate result. That's all. Thank you.